Hi Cougars, in this video I'm going to give a math lecture about fractions. So yesterday we talked about education standards. Today we're going to look at a new math mantra to see if we can decode it, just like we decoded that first standard. Today's math mantra is what you do to one side, you must also do to the other. Yesterday, we also talked about whole numbers, fractions, and mixed numbers. Let's review those concepts one more time. Whole numbers. 1, 2, 3, 5, 7, 9, 12, 15, 20. These are all whole numbers. They are not broken into parts, and that should say they, but it says the. But it should say they are not broken into parts. These are all whole numbers because they're not broken up into fractions. Fractions, okay, so what's a fraction? A fraction is any part of a whole. For example, you can have a part of a candy bar, and this part here is 1/4 of the candy bar, or 1/4. Here we see 1/8 of a pizza, so these are fractions. What about the combination of both whole numbers and fractions of whole numbers? Well, those are called mixed numbers. Mixed numbers, they look like this. Here we have 1 3/4 or 7/4. They're the same. If we have 1 is equal to 4/4. 1 is equal to 4/4. So if we have 4/4 here and 3/4 here, 4 and 3 will add up to make 7/4. Okay, so these are the same. These are equivalent fractions. They have the equivalent value of 7/4 or 1 3/4. What are some ways to represent a whole, parts of a whole, and a mix of the two? That's right, we can represent whole numbers using decimals, percentages, and fractions. Let's talk specifically about fractions. In particular, let's talk about their denominators. First, what does the denominator represent? The denominator is the bottom number in a fraction. It represents how many total pieces of a whole thing there are. The great thing about fractions is that each of these pieces will always be equal to the other pieces. For example, there will never be 1/4 of a whole that is bigger than another quarter of that same whole. If 1/4 were smaller or bigger than the other quarters, then by their very nature, one of those quarters would not be a true quarter. This is what I mean when I say math is about true statements. Okay, enough about true statements. What about adding and subtracting fractions? We're getting to that. First, we have to be ready to obtain equivalent fractions. In case we need to add or subtract fractions with unlike denominators like these, 3 and 4. We see a 3 and a 4 in the denominator, and these are unlike fractions. They are not like each other. They are not the same, so they are unlike denominators. Big question, what is an equivalent fraction? Let's hear from some students. What do you think an equivalent fraction is? The word I'm looking for is value. An equivalent fraction is one of equal value. An etymology or history for the word equivalent. It's from late Middle English, describing persons who were equal in power or rank, via Old French, from late Latin, equivalent, being of equal worth, from the verb equivalere, from equi, meaning equally, and valere, meaning be worth. So root words are important even in math. Okay. So then how do we obtain an equivalent fraction? And that should say fraction singular, but I've got an S in there. So how do we obtain an equivalent fraction? Big answer, we multiply by 1. And I'll show you what I mean. We multiply by 1 because when we do that, we don't change the value of the number we're multiplying by 1. We multiply by 1, and when we multiply by 1, we get a number or fraction that is of perfectly equivalent value. So this should say when we multiply by 1, we get a number or fraction that is of perfectly equivalent value. And I'll show you what I mean. For example, we know that 1 times 1 equals 1, 2 times 1 equals 2, 3 times 1 equals 3, 4 times 1 equals 4, and 5 times 1 equals 5. So why would 1/2 times 1 equal anything other than 1/2? It's going to equal 1/2, right? Yeah. Okay, so we still don't know how multiplying by 1 will give us an equivalent fraction. Tell us, Miss Nikki, how will it do that? We don't know yet. It's okay. We'll figure it out right now. So I'm getting to that. Let's look again at the unlike denominators in these fractions. They are unlike. They're not the same, right? Let's figure out the smallest number that is divisible or can be neatly divided without a remainder. That's what it means to be divisible. It means that you can divide it equally without a remainder. So let's find out what is the smallest number that is divisible or dividable by both 3 and 4. Okay, 6 is divisible by 3, but not 4. For example, if we say 6 divided by 4, we won't get a neat number, we'll get something with a remainder. 8 is divisible by 4, but not by 3. For example, if we divide 8 by 4, we would get a neat whole number of 2, but if we divided 8 by 3, we would not get a neat whole number. We would get either a fraction or a remainder. 12, however, is divisible by both. So in order to be able to easily add and subtract these fractions, they both will need to have a 12 in the denominator because that is the smallest number that they can both go into, right? It's going to be the lowest common denominator that we can find between both 3 and 4. So now we know we need to find an equivalent fraction of 1/3 that also has a denominator of 12. How do we do that? By multiplying by 1. Okay, so if we multiply by 1, we still haven't changed the value of our fraction, right? We say 1/3 times 1 equals 1/3 still, right? We have not changed the value remains the same. Now if we multiply this by 1/1, then we still haven't changed the value of our fraction, right? Because 1/1, that's going to be just 1, right? This number here, this fraction, represents the number 1. So we're still just multiplying 1/3 by 1, even though we've turned this 1 into a fraction. Okay, so let's continue. And we still haven't changed the value of our fraction here. So remember how I said that 4/4 makes a whole? 4/4 is just 1. So we've still just multiplied this 1/3 by 1. So however, we still haven't changed the value of our fraction. We've only changed the form of it, right? We've changed it to a different form. It still has the same value. 1/3 and 4/12, it's the same value here. We have not changed anything. We've only multiplied it by 1. This is because 4/4 equals 1, which I just recently explained, right? So we haven't changed the value of our fraction, we've only changed the form of it. 1/3 is the equivalent fraction for 4/12. 4/12 and 1/3, the same thing, because we've only multiplied it by 1. So we haven't changed the value, we've only changed the form. So I'll remind you again of today's math mantra. Today's math mantra is, what you do to one side, you must also do to the other. This is the case with fractions. In order to preserve the equivalent value, what you do to the numerator, you must also do to the denominator, because it's essentially you're only multiplying it by 1 and you're not changing the value, you're only changing the form in order to get an equivalent fraction. So again, we still haven't changed the value of our fraction, we've only changed the form. Let's continue working together on our place value detectives math packet. Thanks for watching, Cougars. Bye-bye.